All right. You might have noticed we started off with some technical difficulties. I guess that's the price one pays for being in the first slot, or of owning a laptop that's a little roughed up. Who knows, right? We should have a solution where you can see the shared presentation here in a moment. What's the status of that? Let's see. Yeah, you want to join my presentation there. Die Präsentation beitreten. Let's see. Na, du musst eben folgen, was ich mache, sonst geht das nicht. Jetzt? Ah, hammer. All right, so we're working with a little delay here, but I'm sure we can make this work. Moin. Again, thanks for coming to my talk. I hope you're all here to learn something about introducing event sourcing into an existing system. So I like to get to know you a little better before I introduce myself. Who of you already has done some event sourcing in production? That's like few hands, 5, 6, 7. That's amazing. You might not get much out of this. I'm sorry. I hope I can make it entertaining for you anyways. For the rest, I hope this is an interesting journey of how we introduced event sourcing into our existing monolithic Ruby application for the last 3 years. My name is Ole Michaelis. You can find me all over the internet. I have a website that I don't update and a few Twitter and Mastodon things that I don't really maintain. But I'm here, so if you want to talk to me, just find me around for the next 2 days. During work, I'm an engineering manager at DNS Simple. We do domain management, zone management, domain automation. So we solve all your domain needs and pains, working towards being a universal domain control plane where you can manage all your domains across all your providers. But that's something for a different talk. So let's talk about domains, because as I said, this talk is about how we introduced event sourcing into our existing application. So our existing application obviously deals with domains. So if you look at domains and domain management, then you need to learn about the 3 R's of domain management. The 3 R's start with you, the domain registrant. So if you want to register a domain, you are the registrant in this game. And what really is a domain, right? A domain is basically the lease of a name that someone else controls. Because even though you might be in control of that, the TLD, you're just leasing that one out. And that's where it gets really complicated and messy. And fortunately for you, I think, this talk is not about the mess of domain management. We'll have to cover a little bit of this, though, in this talk. So for example, for a .com domain, the registry that owns .com is VeriSign, obviously one of the biggest. And they're really easy to work with, so that's not a problem. But if we think about DE, for example, DNIC, or the even more arcane ones like AF, TU, these are the ones where it gets really messy. So you don't want to deal with them directly, so there's a middleman here. That's the registrar. DNS Simple is a registrar, GoDaddy is a registrar. It's basically the entity that talks to the registry for the registrant. And way too often in this whole game, there's another party involved. And it's also an R. It's not necessary, and that's the resellers. DNS Simple is also a reseller, and this complicates the game a lot. Because in between the registrant and the registrar, you will see resellers. You will see multiple of them, and quite too often, a registrar is also a reseller. Well, what does it mean? This is an example of how we had to transfer and deal with a .au domain. And why I'm showing all of this and why I make you walk through that pain with me is that this is this is why we needed all of this in the first place, right? We have some complexity in our application that we need to solve. So for AU, you or the registrar would always talk to us, to the simple. Then we have an upstream provider. They're talking to another upstream provider that we are also using. So we wanted to transfer that domain from one of our upstream provider to another one. But in truth is that our one upstream provider, Enum, talks to the same one. But what they then had to do, they had to move from their upstream provider, the domain, into a different repository. And they actually never had to talk to the registry. So everyone resells everyone. You don't need to understand this in depth. I don't even understand this in depth, to be honest, especially down here. It gets really messy. What I want to show is that there's just a lot of complexity involved dealing with all of that. And if you don't want to deal with that, you come to the simple and use the simple, and then we deal for you with that, right? So it's a great product pitch that we are solving this pain for you, but if you work for the simple, all of a sudden you have to deal with that. And that was a situation that I found myself in, well, basically when I joined, but it got more and more apparent as I became the now engineering manager. Back then I was the person who had just happened to have the most experience in the registrar system. You might know those people, right? It's like you're the one person that always deals with billing. All of a sudden, you're the billing person, and everyone just shoves that stuff to you. This happened for registry systems with me. So in the simple, we have a system that we internally call the sales order system. It's basically a system that we maintain to get products from any of our upstream providers to our customers. It's basically a container where we can put sales order items into, and then those sales order items have a one-to-one relation to this polymorphic relation we call product. Actually, we don't call it product, we call it something else. That's a really stupid name. We should have called it product in the first place. So you don't have to share this burden with me. For this talk, for the purpose of this talk, we call it product. And these products, as I mentioned, are a polymorphic relationship. So a product can either be a domain registration, a domain transfer, domain renewal, domain auto renewal, a certificate purchase, or a certificate renewal. When I did this talk for the first time about a year ago, we also had 2 more products that we were selling. Luckily, we don't need to, we still offer you Who is Privacy, but we don't sell this anymore. It's a free service we offer now, so we don't need the whole bells and whistles around it. But we also added another product that's still free, but we figured it has enough complexity that we need to add it to the system. So what does the system give us as engineers? Well, we get a certain level of error handling, and with all error handling, it has holes. It's not perfect. We get billing, so we don't need to deal with all the billing, the auth and capture. It gives us a unified admin UI, so we can look into what's the state of the sale. We can retry it if it fails. We can even cancel it. And it also takes care of the scheduling, because it's actually a Rails app. So it usually operates on a per request basis. And then we have cron jobs or sidekick cron set up to actually poke those things that are not done immediate. And as you might already know, domain transfers are never immediate, but truth is that almost no of the domain interactions are immediate. And quite often we sometimes decide to not make them immediate because they're so slow. Because if you talk to Audit is the Australian registry, it sounds obvious when I say this, but you often just don't think about it. They have their data center in Australia. We have our data centers in America. So it just takes the time the light needs to travel from America to Australia, back and forth multiple times, if we want to make a request to them. And this is usually very long. And you in Europe might not want to wait for all the light to travel across the globe. So this is why we force this to be async. So let's have a look at domain registrations in more detail. If you're taking the perspective of being a customer of any registrar service, a domain registration for you looks like a one-stop shop thing, right? It's something fairly simple. And it is simple because the companies who sell you those domains make money out of this, so they want to remove the pain, and that's great. But for us, offering these services, it's way more complex. So what does selling a domain look like for us? So for us, the first thing we have to do, it's a little bit of a legalese thing, but we have to record your intent, right? That you actually accepted the terms of service of the registry, that you accepted the terms of service that we sent you to, that you accepted the price, and that you actually really had the intent to do that. That's something we have to store in our database. Then we are starting the registration at the registrar, and as I mentioned before, for the sake of simplicity, let's just assume this registration just completes on the first try. No error, no async. It's very fast, very slick, no issues. That's like 10% of the cases. Then once that is done and completed, we need to update the local domain to have that domain representation in our database to match the state that we actually need. And then because we are dealing with multiple upstream registrars, we have to make them all look the same to the outside world, because what we are purchasing from them is usually a hot mess and everyone does whatever they think is best. But we need to offer our customers a unified experience of what their domain looks like, talking, for example, about the who is banners that are in there, or domain states. We need to clean up at the registrar. And then we set the domain to register. It's a fairly small thing. We trigger a local event, and when I say event here, I do not talk about the event sourcing type of events. It's a different type of events that we use in our system. And in our system, that event is used for example, tracking. It's an activity log that we give our customers. We use it for marketing emails. It's a slightly different. We also use it for webhooks, which is the next step that we have to do, is we notify customers. We do this by webhook, or we even do this by sending out an email. And then the next step that we do is replace the name server if the customer opted in, but we're talking about registration, so we just set our name servers. And then if the customer opted in, we set the auto renewal setting. All right, so this is what it takes to register a domain for the simple. Now let's talk about my favorite topic, domain transfers, because if you thought that was complex, domain transfers is way more. I don't want to go over all of this in too much detail, but we do intend, we started the registrar, we update the local domain, and as I said, now transfers are almost never synchronous, unless they are, but the default case for transfers is they are not synchronous. There again are a few TLDs that deviate from that. And then we set them up to the same level at the registrar. We refresh the expiration date because we have no idea what we just inherited from this other registrar. Then we update the registrant. So we set your contact details. That's its whole beast in its own. Like I mentioned the other product that we introduced. So we had to build another product. We spent 6 weeks working on this to update the domain registrant, because that's not a simple task. And then we set the domain to register. We update the price because sometimes transfers can be free. That's good for you, but we don't have the intent to pay to charge you if the transfer was free for us. So we have to look back, reverse, cancel the authorization, and do all of that. And then we notify our customers, trigger another event. Then we pull down the delegation, so because we usually don't want to change it. And then we apply auto renewal, and then eventually change the delegation if you opted into this. So as you can see, I've marked a few of those steps with this little icon here. And usually when I do this talk, everyone says the presentation is just not big enough. I think that's not true here. So just raise your hand if you can see anything, if you can't see anything. But I guess we're good here. So all those little boom icons are actually steps where we have to do outside communication. We are talking to our upstream registrars. This involves a network call, at least one network call. Usually it's multiple. And these network calls, as you all know, are like a big source of trouble, right? They can be down, there can be connection errors. As I mentioned, it can just take very long. So when we have to talk to a registry that sits in Australia from our data center in Virginia, it just takes a long time. And it's basically just a big hot mess, because also the vendors we are talking to, even if the issue is not on the network layer, there are still 30-year-old XML, RPC, SOAP-based, whatever APIs that I would say they operate at a best effort. And that hurts. So yeah, it's just a lot to deal with, and we need to embrace error. And that's something I wanna emphasize here as well, is because we are dealing with customers' assets that are way different from what other companies might be dealing with, right? Let's imagine you're working at a gaming company and you're just dealing with like someone sending troops to another village or something. Like if you just have this one entity, that one troop, this one virtual thing disappearing and not functioning, probably don't care as much. But dealing with customers' assets, probably worth thousands of dollars or even 10,000, $500,000, right? Domain assets, domain names can be really, really expensive. We cannot just scratch it off. So we have to deal with every single error and rectify. We cannot just ignore it. So that's why this whole system needs to be very rigid and failure safe. And that's also part of the sales order system that we are getting. We call those failed sales orders. So the sales order can get in a failed state, and then the on-call person would be alerted, and then we have to deal with that. So this is the state of the code, or like a representation of this, when we started our endeavor back in 2020. It's now, and believe me saying this, it is sorted and well named. It was not like that when we started. It's basically the same list of steps that you saw before. It has a little more codey like touch to it. And the container and where this was running is the domain transfer processor. We have, every product has a processor, and the idea of the processor is that it runs all the code that's needed to take one product from start to completion. And what we had is we basically had only 2 entry points into this whole system, which was process, you can think of it as start, and then if something went wrong, we had retry, and that's the second entry point. And from that on, it was basically running as a script top to bottom, and it did not have these nice names, right? It was just the code that actually did the work, but it never, like, there weren't even like private helper functions that actually gave them the names that you see here. So that was the first thing we did. It's like we looked at what do we have and tried to group them and make sense of it and try to understand what business task is actually accomplished here. And all of this and mainly the 2 entry points were based on the state field, and the state was a very annoying Ruby state machine gem that was serving 2 purposes. It was, one, communicating the state of the domain transfer to our customers, which I think they appreciate. But we also used it internally to make a best guess of what we think we need to do. And that was obviously not fine-grained enough. If you just look at the lower block here of all the tasks that we need to do, being transferring or transferred just isn't good enough to convey information of what work needs to be done, right? And if something fails somewhere here in the middle, we had no way to tell where it failed. So I told, would you mind doing this outside maybe? It's slightly annoying. All right, no? Okay, it's fine. All right, so if something failed somewhere in the middle, I have marked it with a little warning sign here. This sales order thing would get into the fail state, and we would see a stack trace in our system, right? We need to go into the logging thing app and read the stack trace and try to understand and look it up in the code of where did the error happen, and then find this piece in the code. And then what we did to fix this, because I told you about the assets and we need to handle it, is that we executed the rest of the block, right? So I went, and we did this multiple times a week. We went into this processor, we copied the code, we set up our CLI in the correct state that the processor would hold, and then we just manually executed those steps. And when we are done, we are updating the state field to whatever is completed, and then the sales order system could take over again and wrap up billing and error handling and all of that stuff. That sounds annoying, right? And let me tell you, it is. It is really annoying. And it might, like, you might say, yeah, it depends on how often this happens. Like, if you do this twice a year, fair, don't bother. But as I mentioned, we have done this multiple times a week, multiple times a day often. So an on-call shift was always, still is, 24 hours. And usually within those on-call shifts, you had at least one or two of those failed sales orders. And because we emphasize our customers and we ask our customers to use our API, customers are really good at automating failure too, right? So if a customer was maybe just not even their fault, if they were unfortunate to start 10,000 registrations while the registry was down, we would see 10,000 registrations that failed because the registry was down. And we all have been aware of this issue, but as you know, there was not like, oh, we can just apply this single fixture and it would all be solved. It was way more complex. So before I talk about how we actually solve this, I want us to all get on the same page of what event sourcing actually is and can do. There's way more to this. This is a very brief overview. There's a gazillion resources out there in the internet that can give you more, but if you have never heard of event sourcing, I want to give you this overview and hopefully give you enough keywords to actually start digging yourself. So in event sourcing, you can look at event sourcing basically as a, maybe you can compare it to ORMs. Or let's put it the other way around. Maybe don't remember that. That's no good. In classical ORMs, you have basically a representation of what state currently exists in the world. Right here, you see one line in your database in what we would call the domain registrations table that's representing a single domain registration. It consists, when it starts, of the ID, the name, the state new, and it doesn't have any failure. And then a failure would happen, and you would go to the same row and update that row. You would set the state to registering, and then you would know the failure, and our system would know then if a failure is set, it's actually failed. And then someone goes in, do the steps that I just described, all this manually working thing. And if they did everything right, they would also update the domain registrations table to look like this. So then there would be, the failure would be nil and the state is registered. And what happened way too often is because the team grew and we are now about 15 engineers, and me being very well versed of what the registrar system is, some people might not have done it like completely correct because it was like 20 different steps that, even though they were documented, they were like super fuzzy and super annoying. And we ended up with what you see now at the right-hand side. And I, coming in maybe after a weekend, looking at the failure, trying to understand what actually happened to rectify it, is that the data was gone. Right? The failure message was overwritten, and we've never seen it again. And that's pretty annoying, right? We had no trace of what actually happens. And this is how you usually do ORMs. Now, let me tell you about how event sourcing can solve that problem, and a few others, but also that problem. So a different approach to achieve the same result would be to not log and update the single database row that you're having, but rather just have an append-only log or an event store, where you log different events. And here we start at your left-hand side and then go over to that as the time progresses, right? So it starts out with a domain registration requested event. And what's important, events are only recording history that actually happened, right? So it can be that it's always past tense. I think that's what I want to say. And as long as you stick to this, it all starts to make sense. So it starts off with the domain registration requested event. Then we have the domain registration started event. Then that failed, so we have a failed event that also has a failure field right now. And then we have a domain registration retried event, and we end up with a domain registration registered event. So now we have, let's talk about a database because that's a concept I think we're all familiar with, is we have those 5 database rows. But we still need to make sense of this and get back the same representation. So what you would do is you would roll up those events called on a stream. So that black line is called an event stream. And roll this up into what's called a projection. And that is the same data we had in our ORM, right? So you can roll up these events going back through the history of what happened to this one domain ID and still end up with the same representation while maintaining history. How cool is that? When I first heard about this concept, I was pretty amazed and thought like, oh, that's so cool, I want that. Because you can, having this, you can do all sorts of crazy things with that. Imagine you have, and that's the tool I always want to build, is imagine you have a UI where you have a slider and you see your representation of your projection, and you can just slide through the events and see it progressing and see the fields updating. And you can get back to any moment in time, basically, of your application. This always sounds amazing to me. I want to have that. Just don't have time to build this. There's way more to event sourcing, and I mentioned this because people just too often throw all of this in the same bucket, and it's like, oh, that's way too much. And if you look at it that way, I would agree, it is way too much. But there are other concepts that are not event sourcing that are really great. For example, domain-driven design. It goes together really well with event sourcing, but you don't have to do that, right? You don't have to do DDD in order to get the benefits of event sourcing. You don't have to do CQRS in order to do event sourcing. You don't have to use the key value store. You don't have to use Kafka. Like, I don't know, people get so obsessed about it, but you can just store your events and transport your events whatever way you want. Like, we just do it within a single Ruby process and do it in a for loop. So that works too, right? And there are a few more keywords that I've briefly mentioned. There's event streams, there's aggregates and projections. There's a gazillion good books about event sourcing. But I think we've just established enough details to now move back to our sales order stuff and try and see and understand of how we actually solved it. And you might already guess what we did, right? So what we did is we looked at all the steps that we need to do and all the steps that we did identify. And the first thing is, after we have understood the domain and the business steps that had to happen, is that we started recording events. We didn't change anything else. We just introduced a new line in this big processor container. We were like, oh, we'll do this. And now, oh, this happened. And then what we ended up with is the system still working as before, good or bad, but no changes. But we also had this additional view on top of those existing things to see if we really captured everything and if we could rebuild the same data structure that exists in the database. So it was like a fail-safe method to slowly introduce a change. That was really cool. So that's the new evented domain transfer processor. It did a step, and after we've introduced events, the next thing that we did is we wrapped the code above the event into what we now call a command, because we know the moment we log the event, we know all the events that, all the steps that should have happened as part of this are above it. So we could just wrap the code that were above logging the event into a single command, and then the command would also take over issuing the event. So now we have a single command that we can call that does what it's supposed to do. For example, start transfer at registrar, and once that is completed, it could also log the event. Because it's logging the event, we can also now understand which of these steps that we know need to happen actually happen already. So that's pretty cool as well. Additionally, every step was or should have been designed to be idempotent and could be retried if necessary. We tried to design them as small as possible to understand or to make them idempotent and have better steps inside it and then intermediary steps. We were able to decouple the state that we need internally from the state that the customer needs. And actually, we just discarded the state that we used internally at all. We only project the state that we're showing the customer now, because we are not even updating the state anymore, the state field. The state field was the first field in the old Ruby model that we actually projected. So we read through all the past events that did happen, and then we were updating the state field accordingly. So for example, you see a requested event, you see a transfer request at a registrar event, we would set the state to transferring. And then we continue processing the events that happened. And the moment we see the transfer, I think here it's a little different. Here we set the domain registered event. We would set the transfer state to transferred. So we would read back and project state. We had a detailed tracking for debugging. So now it was really clear which of these steps already happened and which needed to be executed. And we also had better visibility into input and output of a single operation, because now that command was just returning the one object it was dealing with. And also recovering from failure is easy, because as I mentioned, ideally all of these steps are idempotent anyway. We can group the steps, we can understand which steps ran. And if we had a function that was not idempotent, either because our implementation wasn't proper, or maybe because the registrar couldn't handle it. For example, starting a transfer is something you don't want to do again, right? It either worked or it didn't. And if it didn't work, you would just go in and start a complete new transfer. This would be a new object, right? It's not on the same transfer you would try to restart. But if we ended up in such a case, for example, where the transfer started at the registrar, but because of a timeout, and we talked about time and needs, right? Because of a timeout, our end turned timeout it and we couldn't record the order ID, we would go in and record the event that happened manually, and then the system could just take over. So you would just like record or re-record or recreate the events needed in history, and it would just like continue on from there. And that was really amazing. So yeah, from there, just draw the rest of the fucking hour. I think I just explained that that process already. So here's a little bit of code. If this would be my laptop, if you could see here, I would have loved to also show some current code. Unfortunately, I cannot do this right now. So if you want to look at what we have right now, we can do this. We can do this after the talk. You can just like come here and I can show you little bits and pieces. But the majority of benefits that we gain from this are still captured and are visible here. So what you see here is what we call the processor. So that's the one entity that's responsible for taking a product from end to finish. And here it's the transfer product. We have advanced this that we don't need the big if-else branching there at the top. What we would do right now is we would have just 3 lines of code that say transfer, transfer, refresh, finalize. And those 3 steps. And they would always run and they would just early return or not enter if there are steps in these processes that still need to happen. So, and this is one of those processes. And that's actually one of the things that I want to say like the most proud of, or something that's, at least to me, very pleasing. Because what you see here is what it takes, the simple, to complete a transfer. And you have seen all of this, right? Nothing here should be news to you, because I have showed you what it means to actually complete a transfer. And this is what it looks like in code. So if you look in our code, the processor, the big entity, refers to the sub-processes that exist. Then these sub-processes are aware of what commands need to run and what of these commands already did run, and they could just continue the process. The process can also tell as a whole if it did complete already, because a process in itself is only completed if all the sub-commands in it already ran. And what you see here in the execute block is basically a very small helper functions that are just referring to the command and execute the command if it hadn't run yet. So this is how we do the projection. This also now looks a little different because we are now projecting more states than, or we are projecting more fields than just the state name. But it's basically just the description of what I mentioned before. Like we are rolling through all the events that happen. We start, we usually start, that's not in here, we start with the default event. We nowadays also define the default. In pure event sourcing theory, that should be done in aggregate, but whatever gets the job done. And I think it's really nice to understand how certain fields end up at a certain state, if you look at that. And that's our admin UI. So that's the internal admin UI that we get when we look at a domain registration or any domain transfer. We get a big list of events that happened on those products. We also get to know when they happened, and also we get an actor, so who triggered that. Because it's sometimes important if it's an admin, if it's a registry, or if it's a customer. For example, if a domain registration cancellation requested event pops up, you really want to know if it was us, if it was the customer, or if it was the registry, right? When someone requested a cancellation. So that's something we basically get out of the box because every of our events hold these actor fields. And we were lucky because we already had a concept of an actor within the ensemble. We could just reuse that. So let's wrap this up and let me share you what I wish I would have known 3 years ago. And many of those things I probably wouldn't listen. It's like, I know enough of that. So we'll come to this as the last point here. But what I want to start off of is that always use unique IDs. Because especially if you look at an event source system, what you will need later on is that the ID of your projection or the ID of your event stream should be something that does not depend on your database. If you use the regular, we use Postgres, the regular IDs that are sequence numbers, you always need the database to rely on give you the next ID in line. And that's really annoying if you need the ID very at the top of your processing, but it actually is only generated at the very bottom. So that's very annoying. And we haven't solved this yet. We are actually creating this database record first thing outside of all the event sourcing, and then we go from there. Another thing that I actually did here before, and I did do, is planning our storage requirements. These events just occur a lot, right? Storing a single database row for registration versus storing 14. Doing many registrations actually just scales up a lot. And why I'm sharing this here is I think I just drew the wrong conclusion. What we did is we decided, like, well, if a registration hasn't been touched for like 3 months, who actually needs the events anymore? And we decided to we call this archive. We just delete all the events and make sure you cannot modify the database row anymore. And again, think about it might sound stupid or like the wrong conclusion, and I agree it is the wrong one, but we were operating in a system that's like over 10 years old, right? So I basically now leave out all the things that prevented us from doing certain things. So even though this decision may sound stupid, me explaining this here like without you knowing all the context, and you probably don't care because we all have our own monolith to maintain, right? I think the solution that I should have drawn is to just set up a new storage for events. Do something that you can solve, like pick something you can solve with money, right? Just throw money at the problem and they give you more database space. AWS, I've heard, does that quite well, even though I'm not a big fan of the services. It's actually easier to scale a Postgres or any data store in their system than what we have in San Jose, where we just need to put in bigger disk and migrate a Postgres on the fly. That's no fun. So yeah, that's what we're doing right now. And actually, while I say it wasn't the best conclusion, we actually never had a big issue with that. I just feel it's the wrong thing to do. It's not technically excellent, but we never had an issue with that. Then in backfilling events, when we introduce all of this, we're like, yeah, we now have this. Let's just backfill all the events we can think of all the registrations we ever done, because we did this storage thing only afterwards. And that obviously wasn't smart. Now knowing that we archive events, it might sound logical. But I think what I want to point to is just be smart about it, right? You might need to backfill events when you introduce this, but think about what you need to introduce. I think what we should have done is just look back to a certain time frame, like a year, and then only backfill roll-up events. That's another technique in event sourcing where you can basically replace 10 events with a single event and have your code do the same thing on that single event. And that helps you just to make this a little more obvious. One thing we did right, though, is we have been very cautious about who we put as the actor, because we didn't put system, because system just generates a lot of events. We actually put in my coworker Carlo, and while this, that could have been a better decision to pick like a more generic name, we to this day know which events have been generated as part of the backfilling because they were done by Carlo. So I think that was a good decision. And then it's really important to get your event names right, because if you start introducing event sourcing, what you're actually doing is you're migrating your schema off of your database into your code base. And because you're persisting event names into the database, and as I mentioned before, in an event store, in the ideal greenfield by the books world, is an append-only store, so you can never change it. So changing event names is really annoying, and you should never do this. So before you start, think about how you want to design your event names. Think about the pattern you want to apply. If it's too generic, if it's too big, I think we went too specific. We should have been more generic. But this is not. I'm not saying like everyone should be very generic, right? It depends a lot on your context. So that's what comes to point 5. Is like think again, and make it aware of your environment and your situation, like the problem and the monolith or the software system you're working with. And then I think that's my main point, and I kind of draw back to the event sourcing introduction, is that you don't need all of the stuff that's written in the books, right? The people who are advocating very loud about event sourcing, fortunately often say this themselves, like you don't need a framework. You don't need this super fancy, all of of this in a big box kind of solutions, you can just start by recording events in your Postgres database, right? This works. This gets you a feeling of if this is something good or not, right? I think it's especially if you're introducing this in a monolith, it's really important to think about your environment. So I talked about the failed sales orders, right, and how annoying they were. So once we had the system out, it didn't solve that. Registrars were still unreliable. Networks were still timing out. But what it enabled us, and that's my main point here, it gave us the tools that we needed to actually start solving these problems on the long term. So we now know where to automatically resume a process if it failed. So we set up this alarm, and at the beginning of the year, it triggered for the first time that we had 7 consecutive days without any failed sales order. And that's has been something the company talked about since I joined. I remember on our first meetup in France in 2017, we were sitting down at our CEO's office. It's like, yeah, imagine that. That's the goal for next year. We do 7 days without a failed sales order. And everyone just cracked up laughing because that was totally not feasible and not even realistic. And I remember the goal we set back then was, let's do 3 days. And we totally didn't achieve that. And most of the people who were at the company at the beginning of this year weren't even around anymore. So it was just the 4 of us who actually remembered that conversation. It was actually Amelia. So she actually was also celebrating this a lot. And this was for us a big achievement, that we were able to free ourselves from this drag of operating these systems and taking care of these sales orders. So yeah, that's everything I got for you today. Thank you.